And here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So this morning, first of all, we've got some questions that you asked from section, I guess they're all from 7.1, and then if you have anything from 7.2, and then eventually we'll go on and take a look at 7.3. But let's get started with questions that you asked. So this first one is from section 7.1, number 15. And this is what the problem says. We have 5 times the quantity t minus 1 plus 5 over 5t plus 5. I just want to remind you, we can reduce out common factors, but not terms. Now, let's take a look at that. For instance, this 5 and this 5, they're both terms, okay? This 5 is a factor of this, but it's not a factor of the whole thing, okay? So we still can't even reduce out that 5. Well, now that I've made a mess of things, let's go back and recopy that. Let's see, this was number 15. 5 times the quantity t minus 1 plus 5 over 5t plus 5. What I'm going to do, first of all, I'm going to simplify the numerator. So I'm going to get 5t minus 5 plus 5, which is 5t over 5t plus 5. I can factor a 5 out of the denominator and get t plus 1. Okay? Any questions so far? So now this 5 in the numerator and this 5 in the denominator are factors of the entire numerator and denominator. So we break it down to t over t plus 1. That's as far as I can go because this t in the denominator is not a factor of the whole denominator. Okay, so I can't reduce out the t's. That's our final answer. Any questions there? Okay, we have a similar situation coming up. This is number 17 from 7.1. It says simplify, assume that the denominator is not 0, and we have 64 minus 8h divided by h squared minus 64. Okay, so I'm going to factor an 8 out of the numerator and get 8 minus h. I'm going to factor the denominator. It's the difference of 2 squares, h plus 8, h minus 8. But take a look at this pair of factors. 8 minus h over h minus 8. That's that doggies and cats problem. So what does this reduce down to?
1.
Not 1.
-1.
-1. Okay, remember they're opposites? So that gives me a -1. So now what have I got? I've got -1 times 8 or -8 over h plus 8. And you could write the answer that way, or you could put the negative sign out in front of the entire fraction and write it that way. Okay? Any questions there? All righty, give me a minute here. Let's see, we're gonna go to another student's question, so hang on. And let's see here, 4781. Okay. And this is again 7.1. This is number 15. 14 coming up. This is very similar to the one we just did, okay? But different numbers. So we've got 7 times the quantity t minus 1 plus 7 over 7t plus 7. So simplifying the numerator, 7t minus 7 plus 7, or 7t, because these would cancel. Factoring a 7 out of the denominator, 7 times t plus 1. So far, so good. We can reduce out the common factors of a 7, and we're left with t over t plus 1. All righty. And now let's see. Okay. Here. And again, this is 7.1. Number 14 and 15. Okay. So this is number 14 from 7.1. And it says simplify, assume that the denominator is not 0. 18c squared minus 18d squared over c squared minus 2cd plus d squared. All right. So in the numerator, the first thing we could do is factor out the 18, which would leave c squared minus d squared behind. Then we could factor the c squared minus d squared into the difference of two squares. So I get 18 times c plus d times c minus d. Okay. In the denominator, we're going to get c minus d times c minus d. That is a perfect square trinomial. So bringing those over here, we can now reduce out a common factor of c minus d, which leaves us with 18 times c plus d over c minus d. Now, it doesn't specify whether to leave the denominator or leave the fraction factored or not. So I'm guessing you could leave it this way, or you could write 18c plus 18d over c minus d. Either one of those should be acceptable, correct answers. Okay, any questions on that one before we go on? And let's see, we're going to look at yet another example of number 15.
We don't have to do that one.
You don't have to do that. Okay, we'll skip that one. Thank you. And we'll go to 7.2. Okay, let's see here. 7.2. We're going to start with number 7. Okay, so this is 7.2, number 7. It says multiply and then simplify if possible. Okay, so we've got 7y minus 49 over y minus 7 times y over 7y squared. Okay. The first thing I'm going to do is factor. I can take a 7 greatest common factor out of the first numerator. So I'm going to get 7 times the quantity y minus 7 over y minus 7. Okay. So this becomes that. And then let's see. Oh, the common factor of y minus 7 reduces down to 1 over 1. The 7 over 7 reduces down to 1 over 1. And the y over y squared reduces down to 1 over y. So in the numerator, I've got 1 times 1 times 1. And in the denominator, I've got 1 times 1 times y. So I've got 1 over y is my final answer. All righty. that takes us to number 17. We good to go on?
Yes.
Okay, this is 7.2, number 17. It says divide and then simplify if possible. So we've got 3x plus 6 over 30 divided by 3x squared over 18. Well, the first thing I'm going to do is change dividing by a fraction into multiplying by its reciprocal. So I get 3x plus 6 over 30 times 18 over 3x squared. Again, dividing by a fraction is like multiplying by its reciprocal. Then I'm going to come in and I'm going to factor that numerator by taking a 3 out and get 3 times the quantity x plus 2 over 30 times 18 over 3x squared. Okay, so now let's do some reducing. Let's see. We could take this 3 and reduce it down to 1 over 1. We could take 18 divided by 6 and get a 3. 30 divided by 6 and get a 5. Well, this x is not a factor of the entire numerator, even though this x squared is a factor of the denominator. So I can't do anything more with it. So I've got 3 times the quantity x plus 2 over 5x squared. Any other questions about that one before we go on? Okay, we good to go?
Yes.
Number 30 coming up. Perform the operation and simplify if possible. We have 7x squared plus 59x minus 36 over x plus 9 divided by 7x squared minus 67x plus 36 all over x minus 4. Okay, so dividing by a fraction is like multiplying by its reciprocal. So the first thing I'm going to do is change this division problem into multiplication. So we'll get 7x squared plus 59x minus 36 over x plus 9 times x minus 4 over 7x squared minus 67x plus 36. Okay, I can't factor the x plus 9 or the x minus 4. So let's take a look at that. I'm going to use factoring by grouping. If you want me to use the trial and check method, well, say so and I will. But just taking this, let's see, 7x squared plus 59x minus 36. A is 7, B is 59, C is negative 36. The product is something big we'll come back to. Let's see. I'm going to use my calculator. I'm feeling lazy. 7 times negative 36 is negative 252. Wow. Let's see. Negative 252. And the sum is 59. So I've got to have two numbers, one positive, one negative. But when I add them together, I get a positive 59. Wow, we're gonna let's take this and let's go on to the next page, and then because we're gonna need more room here. So the product is negative 252 and the sum is 59. Well, let's see. How about 252 and negative 1? That would give me a sum of 251. Well, 252 is even. Half of that would be what? 126? Is that right? That'd be 240, 250. So if I cut the first one in half and double the second one, I'd get 124 as a sum. Half of that would be 63, and this would be negative 4. Oh, that wasn't too bad. Okay, so 63 and negative 4. So I'm going to go back here and I'm going to take, let's see, 63 and -4. I need more room here. Okay, what I'm going to do, I'm going to take this and split it up according to the 63 and the -4. Okay, so I'm going to go down to another screen. 7x squared plus 59x minus 36, and we're going to split 63 and -4. So I get 7x squared plus 63x minus 4x minus 36. Are you able to follow all this going back and forth like that? I guess I could write really small and get it all in there, but all right. So now splitting it up, factoring by grouping, we get 7x, x plus 9, x plus 9 minus 4, x plus 9, 7x minus 4. Okay. So that is going to go in the place of that back up 2 screens. So that's going to be, let's see, what is it? X plus 9, 7x minus 4. So 7x minus 4, x plus 9, x plus 9, x minus 4. Okay, so far so good. So now we're going to take this one and factor it. 7x squared minus 67x plus 36. Tell you what I'm going to do. This is all in the recording anyway. So I'm going to erase this and write my work there. Okay, so I've got 7x squared minus 67x plus 36. A is 7, B is negative 67, C is 36. The product is that positive 252? And the sum is negative 67. So, oh, now my sum is negative, which means my bigger number is negative. So I'm going to go negative 252 and positive 1, which is negative 251. Negative 126 and positive 2, which is negative 124. Negative 63 and positive 4. I've messed up. Here's what I've done, okay? If it's going to be a positive product, both numbers have to be positive or both numbers have to be negative, don't they? Yeah. So what that means, that's what I get for trying to write all this stuff here. So basically, they both have to be negative. So this would have been negative 253. This would have been negative 128. This would be negative 67. So there's our 2 numbers. I got suspicious when I had it added up to 67, but it didn't because of the signs. Okay. So now I'm going to take this and split it up according to that. All right. So here we go. Let's see here. Again. Let's see, I've got 7x squared minus 67x plus 36. 7x squared minus 67x plus 36. Is that right? Okay, and then minus 63 minus 4. Split it up, 7x, x minus 9, x minus 9, minus 4, x minus 9, 7x minus 4. That's going to go in the place of that, back up there. So x minus 9, 7x minus 4. Okay? All right. Boy, that's a long problem, huh? No wonder you wanted me to do it. So let's see. The x plus 9 is reduced to 1 over 1. The 7x minus 4 is reduced to 1 over 1. and we're left with x minus 4 over x minus 9. And there we have that one. Any questions? Okay, now we're going to look at problem 32. So 7.2, number 32. It says perform the operation and simplify if possible. Y minus 3 over y times 3y over 3 minus y. Compared to the last one, this one's going to be nicer. Well, let's see. I could reduce the y and the y to 1 over 1. But take a look at this. There's that doggies and kitties, isn't it? Y minus 3 over 3 minus y reduces down to a -1. So in the numerator, I've got -1 times 3. In the denominator, I've got 1. So my final answer is just -3. I like that problem a whole lot better than the last one. Okay with that? And one last one, and this is number 33, part A. It says, perform the operations and simplify if possible. So we have 5a minus 20 all over 2 times 2a minus 8 all over 5. Okay, I'm going to factor this and this further. So I'm going to get 5 times a minus 4 over 2 times 2 times a minus 4 over 5. Be careful. The a minus 4s don't reduce out because they're both on top. Okay, what does reduce out? The 2s and the 5s. So we're left with a minus 4 squared, or you could FOIL it out and get, I suppose you could write that, or you could write a squared minus 8a plus 16. So that, or that, or that. And let's see, they have that answer, but they all should be correct. Okay, that takes care of the questions that you asked me. Anything else before we go on? All righty. Well, then let's go on to section 7.3. So the first thing we're going to do is adding and subtracting fractions with like denominators. So let's take a look at some basic arithmetic fraction problems. Let's say I have 3/5 plus 1/5, that would be 4/5. Or if I have 7/8 plus 3/8, that would be 10/8. So if the denominators are the same and we're adding, we add the numerators. Now, 10/8 could also be further reduced down to 5/4. Okay, whereas 4/5 on the top doesn't reduce. Let's say I've got 17/3 minus 14/3. Well, subtracting two fractions with the same denominator, you would subtract the numerators over the common denominator. And 3/3 reduces down to 1. Okay. All right, so now we're going to apply that to algebraic or rational expression fractions. So let's say we've got 9 divided by x plus 2 divided by x. We're adding two fractions with the same denominator. So we're going to add the numerators over the common denominator, and nothing can be simplified further. Let's say we've got 7 over 10 plus 3y over 10. We add the numerators, 3y plus 7 over 10. Now be careful, 3y and 7 are not like terms, so it doesn't become 10y, it's just 3y plus 7 over 10, nothing can be reduced. Okay, let's take a look at this one. Y plus 2 over 10z plus y plus 4 over 10z. This becomes y plus 2 plus y plus 4 over 10z. We add the numerators over the common denominator. Simplifying the numerator, we get 2y plus 6 over 10z, but we can factor a 2 out of the numerator, and then we can come back and reduce the 2 and the 10 to 1 over 5, so we end up with y plus 3 over 5z as our final answer. Any questions about that? Notice again, I can't reduce it there or there or there or there or there. It has to be factored completely in the numerator. Okay. Let's see here. How about this one? 2 divided by r squared minus 3r minus 10 plus r divided by r squared minus 3r minus 10. We're adding 2 fractions with the same denominator. So we're going to add the numerators. So we're going to get 2 plus r, or r plus 2, over r squared minus 3r minus 10. However, I can factor the denominator into r plus 2 and r minus 5. So now I can come back and reduce the common factors and end up with 1 over r minus 5. Careful, these reduce down to 1. They don't cancel. There's still a 1 in the numerator. That's not equal to r minus 5. Okay, so don't make that mistake. We doing okay?
Yes.
All righty. Just wanted to see if somebody was still alive out there. Okay. Let's take a look at this one. T over t squared plus t minus 2 minus 1 over t squared plus t minus 2. Excuse me. Subtracting 2 fractions with the same denominator, we subtract the numerators over the common denominator. So that would be t minus 1 over t squared plus t minus 2. However, I can factor the denominator into t minus 1 times t plus 2. And then come back and reduce out the common factor and get a final answer of 1 over t plus 2. Okay, let's see here. Y plus 8 over 2y times y minus 14 minus y over 2y times y minus 14. So that would be y plus 8 minus y over 2y times y minus 14. Okay. Now, simplifying the numerator, the y and the minus y would cancel out. So now I've got 8 over 2y times y minus 14. I could reduce the 8 and the 2 to 4 over 1. So now I've got 4 over y times y minus 14, or 4 over y squared minus 14y. Either one of those answers should be acceptable. Any questions there? We good? Okay. Now, here's where things get tricky. 5x plus 8 over 3x plus 15 minus 3x minus 2 over 3x plus 15. Up until now, all the examples that I did that were subtraction, the second fraction had just one number in the numerator. This problem has two terms. So here's what we've got to be careful to do. This is going to be 5x plus 8 minus the quantity 3x minus 2 over 3x plus 15. If you don't ultimately take a minus times that whole thing and distribute it, you're going to get wrong signs on your numbers. So I'm subtracting all of that, okay? So then this becomes 5x plus 8 minus 3x plus 2 over 3x plus 15, which is 2x plus 10 over 3x plus 15, okay? That's going to be very different than if you ended up with minus 3x minus 2, which is what you get if you don't distribute that. But now I can factor a 2 out of the numerator and a 3 out of the denominator, reduce out the common factors of x plus 5, and I end up with 2/3. So again, you're subtracting that whole quantity. There's a good chance you'll see one of those on your test, if my memory serves me well, which some days are better than others. Okay. Now, let's do one more of those. Let's say I've got 7x plus 7 over 5y minus the quantity 2x plus 7 over 5y. So that's going to be 7x plus 7 minus the quantity 2x plus 7 over 5y, which will be 7x plus 7 minus 2x minus 7 over 5y, which is 5x over 5y, which reduces down to x over y. Okay. All right. New idea, same section, but new idea. It says, find the LCD of each pair of rational expressions. All right. Let's review how you find the least common denominator. Sometimes it's really easy. You can just see it. Other times it's a little more complicated. And so you kind of have to go through a process I'm going to talk about. Let's say we had 5/6 plus 2/15. Okay. Now, a common denominator would be 6 times 15, which is 90. But that might not be the least common denominator. And in arithmetic, you can get away with that just using that big number. But in algebra, which is where we're headed here shortly with this, you want to keep it, you want the least common denominator, not just any common denominator. So what we're going to do, we're going to take each denominator and break it down into its prime factors. So 6 becomes 2 times 3, 15 becomes 3 times 5. Okay. The least common denominator is going to be the product of the highest power of each different prime factor within all the denominators. Now, I have 2 to the first power, 3 to the first power, 3 to the first power, and 5 to the first power. Here, I'll put those implied exponents there. So the highest power of 2 is just 2 to the 1 power. The highest power of 3 is just 3 to the 1 power. The highest power of 5 is just 5 to the 1 power. Oops. So my least common denominator of 6 and 15 is 30. Okay. Now, I'm going to look at another example just to make sure that you're getting this. Let's say I've got 27 over 50 plus 5/8. Okay. So 50 would be 2 times 5 times 5, or 2 times 5 squared. Okay. 8 would be 2 times 2 times 2, or 2 cubed. So let's rewrite that. 27 over 2 times 5 squared, 5 over 2 cubed. So my least common denominator is going to be the highest power of 2, which is 2 cubed. I don't take the 2 and the 2 cubed and put them together and make 2 to the 4th. I just take the one that's the highest power times the highest power of 5. So I get what? 8 times 25, which is 200. That's supposed to be at 25. So the least common denominator of 50 and 8 is 200. Okay. All right. So that's a quick review of that. If you need more, come see me during my office hour or text or email me. Now, let's say we've got 4 divided by 9y and 11 divided by 3y. And we want to find the least common denominator of 9y and 3y. Well, 9y is 3 times 3 times y, or 3 squared times y. And 3y is just 3 times y. So I want to form the product of the highest power of each different prime factor. So it's going to be 3 squared times y, which is 9y. So the least common denominator of 3y and 9y is 9y. Okay. I am going to be right back. I hear the doorbell ringing. I thought my wife was here. Give me just a second.
Take the highest power from the least common. I think I get it. Yeah, I get it. Yeah. Do I get it? Yeah, I do. Maybe not. Let's rewatch the video.
I made it back. Sorry about that. Okay. If I die of a heart attack, dial 911, okay? If I pass out here from running up and down. Okay. So let's take a look at another example. M minus 21 over 12 m to the 4th, and m plus 1 over 18m. One of my colleagues was supposed to come and drop something off at 12:30, but they came early, so oh well. All right. So 12m to the 4th would be 2 times 2 times 3 times m to the 4th, or 2 squared times 3 times m to the 4th. Okay. 18m would be 2 times 3 times 3 times m, 2 times 3 squared times m. So far, so good?
Yeah.
So the LCD is going to be 2 squared times 3 squared times m to the 4th, or 4 times 9 times m to the 4th, or 36 m to the 4th. And again, I want to point out, I'm taking the highest power of each prime factor. Not all of the 2's, just the highest power of the 2. Not all of the 3's, just the highest power of the 3, etc. Okay? All right.
I have a question, Mr.
Sorry,
Mayor.
question?
So if none of them have like a higher power than 1, we just take one of them?
Oh, so if there's like a tie?
Yeah.
Yeah, sure. In fact, let's go back here. Here. They both have this just 3 to the 1 power, so you just take either one of them.
Okay.
Yeah, good question, good question. Okay. Let's see here.
Okay.
B plus 1 over 5b minus 10, and b over 6b minus 12. So I'm going to factor each denominator. this would be 5 times b minus, oops, let's try that again. Sometimes the eraser works, sometimes it doesn't. 5 times b minus 2. This would be 2 times, well, here, it would be 6 times b minus 2, which is 2 times 3 times b minus 2. So I'm looking at that and that, okay? So my least common denominator, I'm going to have one factor of a 2, one factor of a 3, one factor of a 5, and one factor of a b minus 2, okay? 2 times 3 is 6 times 5 is 30 times b minus 2. Or you could write it as 30b minus 60. Okay? Questions there? Okay, let's take a look at this one. 7 minus y squared over y squared minus 4. Y minus 49 over y plus 2. Factoring the first denominator, this is y plus 2 times y minus 2. The second denominator is already factored. So my least common denominator, I'm going to need a y plus 2 and a y minus 2. Or I could write it as y squared minus 4. So either of those would be the least common denominator. Okay with that?
Mm-hmm.
All right, now, this next bunch of problems, people get confused, at least the way it's presented in the book here. And let me show you what it says, okay? It says, build each rational expression, or tell you what it says, I guess, into an equivalent expression with a given denominator. Okay, so it has 5 over r and then a semicolon and then 10r. So this is what it says again. It says, build each expression into an equivalent fraction or an equivalent expression with a given denominator. Basically, what they want is that. You're going to take 5 over r and rewrite it as something over that denominator, okay? So how do we build this to look like that? Well, let's take a look at the denominator. What do I need to multiply times r to get 10r?
10.
So if I multiply the denominator of a fraction by a number, I have to multiply the numerator of the same fraction by the same number. So 5 over r becomes 50 over 10r. Now, a common thing people want to do is they say, oh, well, let's reduce that. Well, this problem is about building, not reducing. If we reduced it, we'd get right back to where we started. But we're trying to take this and build it to that. So there's your final answer. Okay? All right.
So you could check your work by reducing it again, right?
Yes, you could, but keep in mind, this is what they want in the answer box, okay?
Okay.
It'd be, well, yeah, okay. So now, let's see here. Let's say I've got this problem. X plus 9 over x squared plus 5x, and then it says x squared, x plus 5. So again, what they want is to get from there to there, okay? Now, what we need to do is let's factor this, which is x times x plus 5, okay? X squared plus 5x, take out an x. What do I need over here? Let's see here. That's not what I wanted to do. Oh, now I've done it. Hang on. Okay. Let's see if oh, I know what I did. I pushed the wrong button there. I'm trying to squeeze that in there, and I don't know if actually I will be able to get it in there. What do I need in the denominator?
An x.
Yeah, I was trying to make more room and I didn't even need more room. So I'm going to have an x on top, which is going to give me x squared plus 9x is going to be my new numerator. Okay? Does that make sense? I hope so, because that's my story and I'm sticking to it. Okay, what are we doing here? We've got 5 more minutes. Let's take a look at this one. 12 minus h. Actually, you know what I'm going to do? I need to start over here so that I have more room to write on the left side. If you would, just planning ahead would help, wouldn't it? Don't worry about me. I'm just babbling to myself here. Okay, and then, so that's going to be equal to 3 times h plus 9, h minus 9. But this is what? H plus 9, h minus 9. So what do we need over here?
A 3.
Just a 3, which means we need a 3 on top. 36 minus 3h is our new numerator. All righty. And let's take a look at this problem. 8b squared over 3b minus 2 minus negative b squared plus 4 over 3b minus 2. So this is going back earlier in this section where we're subtracting 2 quantities with the same denominator. So we're going to get 8b squared minus the quantity negative b squared plus 4 all over the common denominator 3b minus 2. So then distributing the subtraction sign, we get 8b squared minus times a negative is a plus b squared minus times a positive is a minus 4 over 3b minus 2. And then we get what? 9b squared minus 4 over 3b minus 2. Oh, but the numerator is the difference of 2 squares. 3b plus 2, 3b minus 2 over 3b minus 2. So now we can reduce out common factors and we get 3b plus 2. It ain't over till it's over. Yeah, all that stuff going on. All righty. Let's take a look at this. This is a look-alike. Part A says t over 12 plus 5t over 12. And part B says t over 12 times 5t over 12. Let's see. Part A, t over 12 plus 5t over 12 would be 6t over 12, which would reduce down to t over 2. T over 12 times 5t over 12 would be 5t squared over 144. And there's even part C. That's what Moses did, part the C. Okay, which says t over 12 divided by 5t over 12. That's going to become t over 12 times 12 over 5t. The 12s are going to reduce down. The t's are going to reduce down, and I've got 1/5. So operations make a big difference. If you go to the hospital to have your appendix taken out and they take out your tonsils instead, that's not a good thing. So make sure you've got the correct operation that you're carrying out. All righty, so tonight, 7.3, I'll be back at 1:15 with an office hour. Have a great rest of the day, and we'll